So, next speaker is actually a new entry in the lineup. And I'm told that he has very strong opinions about static types and strict types. And he's also a pretty fit guy. He plays American football on his free time. So you might be interested in calling him in case you get into a fight with some Ruby developers about dynamic typing. All right, so ladies and gentlemen, please welcome to the stage Armando and Tobia from Shellren.
Hello, everybody.
Give it a round of applause, come on!
Let me introduce ourselves. I'm Armando, and this is Tobia. We are software engineer in Charente, an hosting provider from Vicenza. Charente operates in Italian territory for over 15 years, offering web hosting optimizer for the main CMS and a dedicated cloud solution for higher performance. Our team focuses on development of applications that manage our business process. Today, I'd like to give you an overview of how to implement a test suite from scratch. In particular, a practical view of the inner working of the test tool for a PHP web frameworks and the challenge experience developing it. The journey we had was not simple and full of bumps along the road. Some choices were not the most efficient, but we believe we can share an interesting insight on the developing process. We will focus on the Phalcon framework, since it's the one we are using. However, the same can be applied for any other frameworks. Today we answer 4 questions. Why did we have need to implement test framework from scratch? What do we want to achieve with the test suite? How we implemented it, the nitty-gritty details. And finally, some remarks based on our experience to understand where are we now. At Charente, we focus on implementing all the functionalities that our company needs. Those functionalities are contained in all-in-one application used for managing e-commerce for hardware and software, a customer help desk to handle tickets, and a task queue for handling the provisioning of service we sell. This application was born as a rewrite for an older legacy system, and we built using the Phalcon, a full-stack MVC style framework focused on performance and low overhead. Phalcon has the distinct trait to be written in C and Zephyr, and bundled and distributed in PHP extensions. We started the development in 2015 with Phalcon 2 and PHP 5.6. The first release was in June 2016, where we updated Phalcon 3. At the time, the testing was limited to manual testing of web pages and the unit testing of simple utilities. This was due to some implementation decision we made at the early stage of the development and a strong dependencies on external resources. The framework didn't have stable test suite tools, and we have added complexity on core classes by extending with our custom logic. We depend on suppliers, APIs, and physical structure like virtualization system and service, which behavior needs to be mock. For a long time, we thought we couldn't afford to address those issues. However, as time went by, we came to the conclusion we couldn't postpone this problem any further. The main reason that led us to want a full automated test at the time was the need to have refactor the core application before moving in Phalcon 4, and the need to migrate PHP from 5.6 to 7.4. Meanwhile, the software also reached a critical mass, and we onboard other developers. During this drastic change, we required a way to assure quality of our software. We didn't want to introduce new bugs or change the existing logic of our features. First of all, we're implementing automatic testing tools. which is our main focus to make sure our changes wouldn't break anything in production. This would also speed up the code review process, since developers don't always run the full test suite locally. And on the test suite, we collect some important performance metric from them. The logical final step after the testing is to configure continuous deployment, since we already have a CI pipeline, and it will speed up the release cycle. Starting out, we evaluated the various approach to how we would test the application. We had identified 3 types of tests that are useful for our needs. Unit test, if you need to assure the result of a single function, is not really viable to test a full application and more useful during development. A functional test limited the scope a single endpoint, but covering indirectly more feature than a single function. And end-to-end testing, you can usually work off application, but it's complicated to pinpoint where the bug, and they're very slow to execute. Our choice was to focus first with the functional test, the middle solution. They are easier to translate for manual testing and automated testing without the disadvantages of the end-to-end testing. Also, they min-max the test coverage, trying to cover more lines of code with fewer tests. And it's the fastest way to start testing the most important and business-critical feature. To be closest to the production database, we have to use the same DBMS. In a memory database will be faster, but has other trade-off, such a different query language, a SQL dialect. It doesn't have the same feature set. The cons of this choice is to have a very high resource requirement on the pipeline and a longer seeding of the data. We seed the data which test independently, and we start from an empty database. The reason is to isolate each test and preventing existing data for influencing other results. Furthermore, we also put each test in a different transaction that will be rollbacked and the end. The initial seeding is nearly impossible, as the relationship between data are complex and difficult to control. We need a builder factory like Laravel styles to have easier time to build the initial stage of each test case. And we help underline the dependencies between models and create a bigger quantity of data in fewer lines of codes, reducing the burden on developers. Also providing stronger contracts between models and dependencies.
Okay, so we were already using a GitLab instance as a version control system and issue management. This already gave us lots of features, of course. Pipeline system to manage the jobs and run tests, Docker runners, artifacts management and test reports, and optionally code coverage. It was already perfectly integrated in the team workflow and the code review process, so we didn't need to spend time integrating third-party services such as Travis CI or others. We also needed a framework that ran the test routine, but we didn't want to reinvent the wheel, so we chose a PhpUnit. We were already familiar with PhpUnit, and it's the most popular testing tool, as we saw in the previous speech. So it was a natural choice. This has gave us basic assertion, as you know, base class to extend the test cases, and last but not least, a CLI utility to run tests locally and on the CI, of course. Then we needed to simulate real data and behavior of classes and external services, replicate physical server structures, have flexibility during development for the expected data and classes that are yet to be implemented, and isolate and easily recreate the responses from API. So to make this data, we chose the Mockery library. All right, so we have an idea on how the pipeline needs to be set up and the test framework we're going to use, so we should be done. But actually, we're just getting started because the hardest task is to integrate the testing framework with the rest of the application, which was already existent. Since we want to test each endpoint, the first is being able to resolve requests. The biggest challenge is resolving the calls to the controllers, since we need to set up the application status and isolate it for each test. So the process was incremental for each type of test and build extend on the previous one. The first is the unit test, the simplest one, but the most important also. And this trait has the job of initializing and resetting the DI. So on setup, we reset any existing DI, and then initiate the DI container with the utilities and services we need on the test. And during teardown, we need to reset the DI again. The model test has, of course, access to models, and it needs a connection to both cache and database. On setup, we set the model manager and model metadata, set the connection to the database, and begin a transaction to ease the cleanup. And on teardown, we reset the DI again and roll back the transaction. The last one is function test, which is the heavier type of test, and need to instantiate the whole application. On setup, we set up the dispatcher, which loads the controllers when we dispatch a URL. We set the PH escaper, which is a fundamental component for URLs on our framework. And finally, initialize the web application, which will handle the dispatch of an HTTP request through an URL. On teardown, we reset the DI, we null the application, and reset all the session variables, such as get, post, etc. We implemented in a different trait each different test functionality, which is used in a class that extends PhpUnit test case. Then the model test extend unit 1, and the function test extend the model test. So each step's built on the previous one, and at the end we have a fully functional application to test, but only initializing inside the DI the minimum services that we need in each test case. We also took inspiration from Laravel and implemented a smaller utility traits that can be used in different test classes while still having access to the DI and the application of the test. We needed to move the request standard to substitute the HTTP call to the controllers and permit the test to manage them. Making HTTP call is slow, so we have to simulate those calls to the controllers. We know the entry point of the framework, but we need to set up the environment and session for each of those calls, leaving the maximum configurability to the test. On internal calls, we substitute the HTTP calls with function calls, wrapped to permit the initialization of variables that are needed by the controller. Some examples of these variables are URL, request server, settings, etc. We take the entry point of the application, we bootstrap it, and execute the call in the test method. Positioning ourselves before the application sends a response, we can intercept the result in order to make assertions on it. For each call, we need to bootstrap a new application instance, since it's a PHP FPN job to normally resolve those calls. We need to make some operation that would have the same operation that would have been done on a real web server, since we don't want to change the application behavior in the test environment. Then we have to test API calls, which is something very hard to do. And we need to do it at every point of the application. And the only way is to leverage the dependency injection and substitute the client object when needed. We set a closure as a DI component, and when we need to substitute a service, we provide a closure with a mode client object with the response we want to have to return. To reproduce request, we can just save a JSON file in the resource folder, and then we make the mode client return the object from this JSON instead of the actual call, making the request replyable. To use these features, we are leveraging PhpUnit hooks to initialize the application. The test bootstraps the application during the setup hook and tears it down at the end. This is to isolate each test case. This creates a problem when working with models because in the data providers we still don't have a database connection. Here's where factories come in to provide an additional level of abstraction over the models. The factories have the dual benefit of maintaining an internal state on how to generate a model, and the logic for physically create one or more instances. This is done to initialize the state of the models as data providers before the application. This also provides a way to create a standard and render model through the Faker PHP package that can be then persisted in the database during the test case. Also, it can generate multiple models at once, along with the ones related, of course. Earlier, we implemented a way to get the result of an HTTP call to a controller. And now we need to improve the checks and assertions around the result, around what the result is. So we created some utility methods leveraging PhpUnit assertions, like checking the status code of the response, check an empty response body, or utilities to check JSONs for the presence or the value of a key. On the other hand, we needed to test the more UI-oriented side of the application, and to do so, we chose the Symfony DOM crawler. Since we don't use a JavaScript front-end framework, we can read DOM, crawl it, and make assertions on what's inside the HTML, like checking if a form is present or the correct filter set on a table. So to give in to the cargo culture, one of our goals is to ship the code as fast as possible to production. To do so, we implemented a CI/CD pipeline that tested the code and deployed it to the production server. We can take advantage of the vast variety of features that are available on GitLab. What we need to do is to register a GitLab Runner, create a Docker image, create the GitLab CI YAML, and then, of course, profit from the pipelines. The GitLab pipeline uses Docker container to run, which we do not use in production. The first thing we have to do is to create a Docker image, of course, that is as close as possible to the production server. However, we chose to use, there are a lot of popular choices, of course, for PHP starting image, but we chose to use Debian image since it is the same distribution we already use in production, even if it's quite a bit heavier than others. An important point is that each step will pull the Docker image again, so it's necessary to create a Docker image with all the dependencies and then push it to the registry. Otherwise, we'll need to download the dependencies each time, of course. After building it, so we push it to the container registry, and in the GitLab CM YAML, we declared the services, like database and cached and so on, and in particular, GitLab gave us the opportunity to use its MySQL service, GitLab CI MySQL. So we triggered the pipeline on merge request. We configured 2 stages, build and test. We cache vendor and generate artifacts. And on a successful test run, we merge in master, and the deployment stage is kicked in. We run with our custom PhpUnit configuration, as you can see, which is nothing fancy, but just a different type of tests, and the bootstrapping with the composer outload. We then export the result report in JUnit format, which is the one supported by the GitLab artifacts. And this empowers us to see a structured report of the test. Not only we can see the standard metrics, like test failed and passed, but we can also see the time of each test, how much time it took, and the exception or assertion that each test made it fail or succeed. And this is useful since it can be then tracked and linked on an issue, for example. This performance metric can then point us to where there are problems in the application for further performance analysis. We collect some tips to organize the pipeline steps, in order to better parallelize the work and have logging for the time of each step, as already said. Otherwise, it's difficult to understand how long a single run have taken. Okay, so we are now approaching to the end of the presentation, but just let me go through the key points of what we learned from our experience. We saw that dependency injection solves all the problems, more or less. We use PhpUnit hooks for the test steps that are very useful. Each test case, we saw that needed to reinitialize the DI and the application state. And we found out Mockery has a fantastic library to prevent API calls. We saw that it's better to start writing simple tests rather than not testing at all. And we saw that feature tests are a great way to cover a large portion of an existing application. Okay, so I hope you enjoyed our journey to how our test suite work under the hood. And thank you very much. And if you have any question. Troppo bravo.
Yes, just a second, we've lost the MC. Please bear with us while we go and find it. There's a question.
Hi, thanks for the talk. I just want to ask, like, how long does the test suite, like you currently, how long does it take to run? I mean, is it like 1 minute, 10 minutes, an hour, just like?
10 to 15 minutes.
Okay, because just it feels like the rollback with MySQL that can contribute to taking more time. But yeah.
Yes, we know it was a design choice because, as said, the application was already existent and was already running and everything. So we needed to choose some to do some choices on how to isolate each test. So we decided to start from an empty database and then roll back each test run. But maybe it will be an improvement to change this behavior and find another solution.
Any other questions?
All right, I'll take it. So I guess we're done. Give it another round of applause to both Armando and Tobia.